All right, we're back. This is page 15 of math analysis. This is notes 2 specifically. And we're going to do the sines, cosines, and tangents of common angles. So these are things you are going to memorize and you're going to use them like a million times. So you almost can't avoid memorizing them. But every year people try to avoid memorizing them and it's not a good time. So you got to do it. So let's see. Use the general ratio of sides in a 30, 60, 90 triangle to find sine, cosine, tangent of both 30 and 60 degrees. So let's see if we can do that. So I'm going to first draw myself a 30, 60, 90 triangle. So go there, there. Should really start with the horizontal. I mean, I feel like that would be the pro way to do that, but not a pro. So this will be 30. And because that's 30, I'm going to call this x. So this will be x root 3, and then this will be 2x. Okay, so now that I have like sides, I can find sine, cosine, tangent for 30 degrees. So let's do that. The sine of 30 degrees is going to be the side opposite, which is x, over the hypotenuse, which is 2x. But then that just simplifies down to 1/2, regardless of what x is, as long as x isn't 0, because you can't divide by 0, and like that's a little weird. But you're just going to get 1/2 no matter what. So let's take a look at cosine of 30. So this is like an exercise in similar triangles. It doesn't matter what x is. The ratios are going to be the same. So the sine of 30 is always 1/2. Doesn't make a difference how big your triangle is. If there's a 30-degree angle, like anywhere in the world, it doesn't even need to be in a triangle. 30-degree angle, the sine of that angle, 1/2. Memorize that. All right, what are we doing here? So we're going to do adjacent. So x root 3 over hypotenuse, which is up there again, 2x. So here we go. Cosine of 30 degrees, radical 3 over 2. No matter where it's happening in the universe, is it in a triangle? Is it just sitting there on a bench? Who knows? Its cosine is radical 3 over 2, and you're going to memorize that. And then tangent of 30 degrees. So for tangent, we're going to do opposite over adjacent. So opposite is x over adjacent is this x root 3. Okay, so then this one is a little weird. So if I cancel, I get 1 over root 3. But we're actually going to rationalize that. So multiply the top and the bottom by radical 3. So the top by radical 3, the bottom by radical 3. In the denominator, you get radical 3 times radical 3, which is 3. So root 3 over 3. That's how you're going to end up memorizing that. So sine of 30 degrees is 1/2. Cosine of 30 degrees is radical 3 over 2. Tangent of 30 degrees is radical 3 over 3. So that's pretty good. Now we want to do 60 degrees. So let's look at the triangle. So should I just draw another triangle? I don't really have room for that. It's like I didn't game plan to do that. So I'm going to use the same triangle and just be, make a mess of it, basically. All right, let's see. So it would be nice, though, if I had put these like on top of each other. Let's see if I can manage that. Go up, go over. Not terrible. I really like that. It's like one of those things like you didn't know how much you were going to like that until you start doing it kind of like full time. And now making these videos and teaching my classes online is pretty much my life these days. So I've come to really enjoy that. All right, sine of 60. That's not a 0, 60 degrees. All right, so we look at it and we're going to need opposite is, here we go. So that's x root 3. And then while we're there, the hypotenuse is 2x, right? So let's just do x root 3 over 2x. Now, something to look at, which just happened, is that the side adjacent to 60 degrees is the same as the side that is opposite 30 degrees, which means that when you look at these, the cosine of 30 degrees is going to be equal to the sine of 60 degrees. And that's because in the triangle, the same side, that x, is adjacent to one angle, it's opposite the other angle. So we got this weird relationship. Cosine of 60 degrees. So you can just look, I'm not going to highlight. Cosine of 60 degrees is going to be adjacent, which is x, over hypotenuse, which is 2x. So that's 1/2. And then if you look carefully at what we got going on here, cosine of 60, same as the sine of 30, for the same reason. The side that's adjacent to 60 is the same as the side that is opposite 30, which I feel like might be what I said last time, but I didn't mean that. Whatever. I mean, I don't think I said it wrong. I think I was just referencing the wrong. I don't even know if I did it. All right, and then tangent of 60. All right, so we need opposite over adjacent. So opposite 60, you're kind of like, you're at 60, you go opposite 60, gives you x root 3. Adjacent to 60 gives you x. So it's going to be x root 3 over x. Over x, yeah. Second there, I was like, what? All right. What you won't notice is that the tangent of 30 does not equal the tangent of 30 doesn't equal the tangent of 60, right? So we have this relationship where sine of 30 equals cosine of 60. The cosine of 30 equals the sine of 60. Think about and think about what the angles add up to and see if you can kind of like work out a thing there. Point being though, sine of 60 degrees, root 3 over 2. Cosine of 60 degrees, 1/2. Tangent of 60 degrees, radical 3. You basically have to memorize those. Not basically, you have to memorize those. Let's do this one also. So here, and then here, and then here. This is definitely not isosceles, but it's supposed to be. Okay, let's say this is x, this is x, this is x root 2. All right, so 45 degrees. I mean, they're both of the acute angles are 45 degrees, so it doesn't matter which one you use. You should use the one on the bottom left, though. That's like the normal thing to do. So this one, it's less work because there's only one, 45 degrees, but it happens twice. So 45 degrees is going to be opposite over hypotenuse. So that's going to be x over x root 2, which is 1 over root 2. But for the same like weird reason, it's really just like historical. We're going to rationalize this, and I'll show the work on this one, which gives me root 2 over root 2 times root 2 is 2. Root 2 over 2. The sine of 45 degrees is root 2 over 2. Cosine of 45 degrees. Well, I mean, look at the triangle and think like, is anything going to change really? I mean, we have to do adjacent over hypotenuse, but that's just x over x root 2 again. So again, root 2 over 2. Tangent is maybe the craziest one. It's definitely, I think, the easiest one to remember. Actually, I personally, when I was in high school, I memorized that the sine of 30 degrees was 1/2. And then once you develop like an understanding of it, that's kind of enough to find everything else. Because if you look, we're not dealing with a lot of numbers here. We got 1/2, root 3 over 2, root 2 over 2. Those are the only values that you're getting for sines and cosines. If you get 1/2 for sine, it looks like you're getting root 3 over 2 for cosine. If you get root 3 over 2 for sine, you're going to get 1/2 for cosine. And then you just start thinking like the sine of 30 degrees is 1/2. The sine of 60 degrees is not the same, so it must be root 3 over 2. And that's when I was in high school, that's how I remembered everything. Interestingly, it's not how I remember everything now. So like it's up to you. Opposite, adjacent, is going to be x over x. So it's just 1. Okay, we got all the values that we need. Let's put them in this table, and then I will stop this video here. So this is, you are going to memorize this. You're going to know it like backwards, forwards, upside down, switch some rows, switch some columns, have it all memorized. So 30 degrees is pi over 6, pi over 4, pi over 3. All right, sine, 1/2, cosine, root 3 over 2, tangent, that's a 3, root 3 over 3. 45 degrees or pi over 4 is actually, I think, the easiest one because it has the least to remember. Because you use the same ratio twice, and then you just get 1. And then this, if you got 30 degrees right, you will definitely get this right. And then this is, so there's like, all of my knowledge is like a house of cards. Like you know, if I bump my head one day and I forget the sine of 30 degrees, sine of pi over 6, it's like all over. But, you know, we have 1/2 here, and then we get 1/2 here. And here we have root 3 over 2 here, root 3 over 2 here. And now they don't have the same relationship, right? They're not exactly equal. But what I remember is that this 1/2 is nice. This is not nice. Whereas over here, so it's all based on signs. This is not nice because of the radical, whereas this is nicer. It's nicer than root 3 over 3, right? It's just root 3. That's how I remember it. Pi over 6 has a nice sine value, so it's 1/2. It has a not so nice tangent value, so it's root 3 over 3. Since the sine of pi over 6 is 1/2, I know that the sine of pi over 3 is not going to be 1/2, so it must be root 3 over 2, which means that its cosine is 1/2, and then I know it has a not nice sine, so it has a nice tangent, so it's root 3. Those are like the weird ways that I remember it. You have to come up with your own weird ways, or maybe not weird ways, however you want to do it. But anyway, this you're gonna memorize like yesterday. Memorize. And then let's see. I would like to have this written several times. So let me copy, paste, rotate it maybe this way. Okay, that's good. And then let me paste it again, rotate it this way. Okay, and then I'm gonna paste it here, and then rotate it. I don't know, like who would write upside down like this? Some kind of weirdo. But anyway, you're gonna memorize that. You need to know it. I feel like there should be one on the top and the bottom also, but I'm not gonna make you watch that. So I'm gonna stop the video here, come back in the next video and do some more. So memorize this. Seriously, you've got to know it. I'll see you in the next video.